Hi everybody, thank you for watching this video. This video has been made by a beginner, myself, so it's a video for beginners only. The expert or experienced guy won't be very enjoyed by this video. Of course, it will be at a high level. The goal of the video is to give an overview of the three main libraries in data science. The libraries are the first one, Scikit-learn, the second one, Tensorflow and Keras, and the last one will be Pytorch from Facebook, Tensorflow, of course, from Google. So we will give this overview based upon a use case. The use case is the cancer breast. So, well, it's not very funny, of course, but the data are very accurate and it will give a very good prediction. So, again, the aim of the video is not to detail how we can achieve to find the correct target, but just to give an overview of the tools, and well, that will be enough for this video, I hope so. So let's jump to the video. Oh, just before that, a small prerequisite, because of course there are specific topics in that kind of domain. So of course you will need to have a basic knowledge of Python. I mean, I'm not a Python developer, but of course you need to know what is a class. Well, it will be enough, I think. And you also need to have a high level knowledge of a neural network. So I won't be able in a short time to give you more details on that topic. So if you don't have these prerequisites, I think it will be sometimes a bit difficult to follow. But well, why not? It could be interesting to test it. So let's jump to the overview. Thank you. So just before starting with the model, I propose to have a quick look at the dataset. Of course, quite important to understand what is the dataset. Well, the dataset is based upon breast cancer prediction. So, well, it's not funny, but it's quite important to have a prediction in this case. So there is 11 columns. It is a dataset downloading from Kaggle. Kaggle is a very good website for data scientist competition. So I encourage you to go to this kind of site to see the model you can find, and well, it's very interesting. So there are many lines, around 700, but it's not too much. And also, of course, an important column, which is the target. So the name is class. And if we see only this column, we can see a column with 2 and 4. The 2 is for benign tumor and 4 for malignant tumor. So this is what we have to predict with the dataset. So of course, in this case, it is the true level, true value, and the model will have to predict this when it will be trained. So let's go back to the notebook. So for this presentation, I have chosen a specific notebook, a very good one, of course. It is Jupyter Lab. This notebook is coming from the Anaconda distribution directly. Well, if you don't want to have an Anaconda distribution on your PC, you can also use a web notebook called Google Colab, for example. So it's also a good choice, and then you will have to download on Google Drive your file and then get a credential to use the data from Google Colab. So in my case it is in my PC. As you can see, there are different windows for every model, every library, and of course I try to have the same point of view for each library in order to be able to get comparison. And yes, as you can see, so if we start with scikit-learn, of course you have to first of all import the library you will need in your script. So of course the goal of this video is not to go deeper in every line of the script, but just to give you a short overview. The very important part, of course, to train a model is to get the good data. So again, it's not the goal of this video, but just a quick overview of what we have done for this. So I have uploaded a CSV file, and then I have changed the 2 by 0 and change the 4 by 1 in order to get 0 or 1 class or one value in the only one class for the prediction, because the neural network is more accurate with this kind of normalization. So we have also a need to normalize the data in the input of the model. So for that, I have used standard scalar. It is a function coming from scikit-learn also, you can see here. And I will use the same function for, well, I think it's a class, it's not a function, but never mind. And also for the other library. So again, as we use a multi-layer perceptron, it's very important. So it's a fully connected neuron, it's not a recurrent neuron, and it's very important to have the input normalize the data in order to help the model to converge. After this normalization, we have shuffled the data in order to avoid any discrepancies between the prediction, because if you have only in your training data set one kind of prediction, of course it won't be very accurate for the test set. And then we split the whole data set into two kinds of data set. The first one is the trained data set, of course, and the second one is the test data set. The test data set will be used to check if the predictions are good or not. And well, of course, it's quite important because we won't train the model with the test data set. We will train the model only on the feature data set, but we need to know if we can expect from the model to be accurate, not only on the trained data set. So it's the reason why we need another data set. So now let's go to the model building. So with scikit-learn, it's very easy. You just have to code one line, and well, I have chosen the classifier MLPC, multi-layer perceptron classifier. So well, for a binary classification, it's of course it's a good choice. And you can see that to define the layer, you have just to put here the number of neurons and for each layer, and of course you could add here another layer. Well, why not do that? And then you just have to mention the activation function. It is a logistic one, so of course again for classification, binary classification, it's quite usual to have this kind of activation function. Well, at the end it will be a kind of sigmoid, of course. And you have also an optimizer, the solver Adam. It will be also used in the other script of the video. And, well, one important parameter is also the number of epochs. So the epochs is the number of time we will train the model with the total data set. So if we train the model with the total data set 2 times, 3 times, 4 times, it's called epochs. So 1 epoch, 2 epochs, etc. For the example, there is no batch size. Well, again, I have chosen a very easy way to demonstrate a model building. So one line, very easy. And then the model training, also very easy, because you just have one line to ask to the model to fit between the feature train and the target train. So you just have to feed the model with the train dataset and the target dataset, and of course the model will try to find the correct target, and the model will adjust the weight of each layer in order to converge with the target value. So, and to do that, of course, you will have to decrease the loss, and the loss is calculated by the loss function. Well, let's launch the evaluation and the training. So as you can see, it is busy. It's very fast. And well, we have used, in fact, now 3 layers. And as you can see, there is a very good prediction, because there is 0 here, 0 here. So it means there is no errors. Okay, it's just an example, but this is the confusion matrix. So with the confusion matrix, you can show the true positive and the false positive, and you can see the true negative and the false negative. So the false negative and the false positive are 0, 0. So, well, it's very good result. So to summarize, very easy model, and well, I think you really don't need to know anything about a model to use this kind of libraries. Well, just a little, of course, but no, really very good library to start with this kind of approach. So now if we jump to TensorFlow Keras, well, again, the data pipeline is not the goal of the video, so it's the same. I didn't change anything for that, but for the building part, of course, it's a bit different. Not too much difficult, but a bit different. We can use the sequential model. So in the sequential model, I have chosen to use the add method, but I could have chosen another way to define all the layers. So as you can see, there is only 2 layers. I'm going to activate this one also for the good comparison with the other. And so you can define the number of neurons for each layer. You can define the activation function. So in this case, I have used the ReLU activation function. So it's linear for positive value and null for negative value. And for the last even layer, I use sigmoid because of, again, it's something like regression logistic regression, sorry. And I have also mentioned here the input layer, so it's not mandatory, but well, if we do that, you can directly get up the details, the summary of the model you have built. And of course, you can see the number of parameters. It's very interesting because, well, there are very few parameters, but in some cases you can get a very important number of parameters, and sometimes we're more than 1 million. So of course you can imagine the time it will take to train the model. And there is also a non-trainable parameter. It's in the case you reuse a, a pre-trained model. So, well, it's not in the video goal, but well, it's also interesting to have this kind of information. Then for the model training, it's quite the same. You just have to add a line called compile. So in the compile line, you mention to the model the optimizer you have chosen. So the same than the one which I've chosen for scikit-learn, Adam. And also you define the learning rate. So it's quite an important parameter, and you can do the same with scikit-learn, of course. And the loss function. In this case, the best function is binary cross entropy, but it could be the square error metric, and there are many other kind of loss function. Again, the idea is to find the minimum level of the loss function, so the minimum loss, in order to optimize the weight of each layer and get the good result. So model evaluation is the same. If we run this, we could have a good result also. As you can see, there is more details because I have chosen Verbose 2 so it can display the log. If I have put 0, it will be hidden. So it's very interesting to have this kind of figure, because you can see here in the loss is getting down, is decreasing, and it's very important that the loss decreasing and the accuracy should increasing. And also it's very important to see that for the validation part, the test part of the model, the validation, part of the model, you can also see a decrease, because if there is a decrease here and an increase here, it means that we are overfitting the model, so it's not very good. It means that we are losing what we were looking for. It means that the model won't be deployed for real data, only for the training data, so it's not the goal, of course. So quickly you see the accuracy near 100, and if we go to the end, we can see that he has found the same result, of course, so no error at the end. Well, again, it's an example. So to summarize, quite easy. You just have to define, and I think it's very comfortable to define every layer, so not very complicated. If we jump to Pytorch, well, we have exactly the same kind of model, sequential model. So I will go very fast. In that case, I am just chosen another way to define the layer. I send the layer directly to the sequential classes. But well, again, it's quite the same. You define the layer, the number of neurons, and then it's the same. The difference is in the model training, because in this case with Pytorch you have to define how the model will iterate the dataset. So, well, of course, it's not so easy than with Keras. So you just have to mention that you will make x epochs, so the number of iteration, and then you explain to the model what you are going to do during the iteration. So, well, you apply the loss function, you measure the loss, and you make a retropropagation in order with an optimization in order to update the weight of each layer. So, well, again, for experienced people, it's not a big deal, but for beginners, it's quite difficult at the beginning, of course. For the other steps, it's the same. So if we run the model, if we run the training and the evaluation, we will find the same thing, of course. And, well, is working? Yes. Up, yes. So same accuracy, just what we have now, and we could have the same kind of curve for the other model, of course, is the loss evolution, and it's very interesting to see that the loss evolution is going down, and, well, after 4,000 epochs, I think we should stop the training, because there is a risk of overfitting here, so we need to be careful. And, well, if we have display the accuracy curve, we will have this kind of accuracy curve here. So it's a very interesting to have this kind of information to tune the model training. Anyway, so model training is very different. You need to define this part of the training. So, well, again, it's not for beginners, I think. And just another way to define the layers is doing subclassing. So subclassing consists in defining a subclass of the class NM module. So it will be my personal subclassing here. And, well, so it's another way to define the layer. And, of course, we can do exactly the same with Tensorflow Keras. There is no difference on this part. So you just have to define the constructor, the number of layer and the shape of the layer, number of input parameters, number of neuron, the activation function, and then you have also a forward function that should be defined in order to explain to the model how the information will go from a layer to the other layer. So, of course, in sequential neural network, it's quite easy. The first layer will send to the output of the other layer its result. So, well, it's another way to define a model. And then, well, you have the same way to define the training and the iteration. So again, you have to go a bit deeper in the code. And then, well, to run, it's of course the same, and we will get, of course, the same result. So to summarize what we have seen, clearly scikit-learn is very good for beginners. It's very simple, and, well, again, I love this library, but of course there are some limits. For many kind of model, there are a lot of different model. There are logic regression, KNN, well, I can't, decision tree, well, random forest. You can find every model you are looking for. But if you are looking for image recognition, there is no convolution layer, and, well, of course, it's very difficult to get image recognition. And also, you haven't anything for NLP. You have no recurrent neural network, no LSTM, no GRU. So, of course, for this kind of goal, well, you cannot use Scikit. You have to use TensorFlow or Pytorch. But for beginners and for something else than image recognition or NLP, it's very good. It's a very good library. Between TensorFlow and Pytorch, well, it's very difficult to say which one is the best. Well, from my point of view, Keras is very easy to manipulate. Well, I must admit that, well, of course, TensorFlow with the version 2 is in eager mode, so it's easier to manipulate the model. It's more interactive, in fact, because it's not only graph approach. But, well, the tensor are more clear from my point of view in PyTorch, and it's very interesting. But again, for skilled people or for expert, I don't know what they think about it, but there is so many differences. And after that, well, the main question is just a game for you to play with the model, or do you want to deploy a model in production for a real business target? And in this case, of course, you have to ask yourself what is the best the best choice, sorry. And I don't know really if TensorFlow or Pytorch is the best choice in this case. But, well, Keras for intermediate level, it's a good choice. So thank you to have attended to this video, and I hope it will be helpful for you.